Engineering Fundamentals from the Appendix B, page number B-7 to B-8 by the manual detailing for steel construction by Yugandhara Tayale. We will apply the concepts learned about forces, moments, and equilibrium equations to some problems. So let's solve them. So this is the example of the concentrated load acting at the midspan of the simply supported beam whose magnitude is 1000 pounds. So this is the free body diagram of the simply supported beam with concentrated load at midspan. We will calculate the forces. So this is the simplest example with a concentrated load at midspan. So at pin support, two reaction components will be there, and at roller support, one reaction component. So applying summation of Fx is equal to 0 as there is only one horizontal reaction, that is HA. So it will be equal to 0. And applying summation of Fy is equal to 0, we will get VA and VB is equal to 500 pounds. How? Because this is the symmetric structure. So this 1000 pounds will be resisted equally by these two reaction forces VA and VB. This is the example where a uniformly distributed load is acting at partial length of this simply supported beam. So how to calculate the reactions? We will see. This is the free body diagram of this simply supported beam with uniformly distributed load acting for the partial length. So first we will convert this uniformly distributed load into concentrated load by multiplying the UDL magnitude by its loaded length and finding out the reaction components according to the type of supports. So this is how free body diagram is drawn. In the next step, we will find out the support reactions applying equations of equilibrium. So this is how the free body diagram of the beam is there. A support, B support. This is VA, HA and VB. And the force of 1000 pounds. So we will apply equations of equilibrium. Summation of Fx is equal to 0, which is HA is equal to 0. Summation of Fy is equal to 0, considering vertical forces as positive. So VA minus 1000 plus VB is equal to 0. That is VA plus VB is equal to 1000. Now we will also apply one equilibrium equation. Summation of moment at A is equal to 0. As at support A there are two reactions, so these two reactions will get eliminated. As at support A the lever arm will be 0 for HA and VA, it passes through the support A, so the moment produced by HA and VA will be 0 if we take moment at A. So considering This is anti-clockwise as positive and clockwise as negative. So at A, do like this: 1000 kilonewton, 1000 pounds force is producing clockwise movement, so minus 1000 into this distance we need to find out into that lever arm, plus VB is producing anti-clockwise, so VB into 10 foot is equal to 0. This is 10 foot and the reaction is at 2.5 feet. I will just rub this so it will be clear. 2.5 feet. So 1000 into 2.5. So after solving this, we get VB is equal to 250 pounds. So inserting this value in the summation of Fy equation, we get VA is equal to 750 pounds. Here, a simply supported beam is acted upon by a force of 1000 pounds at 2 feet from support A. So, this you can practice. In this example, a force of 1250 pounds of the magnitude incline and it is acting at the midspan. So for this inclined load, how and what are the reactions developed at suppose A and B, we will calculate. So this is the free body diagram of the inclined concentrated load acting at midspan of the simply supported beam. We will calculate the reactions. This is the example of inclined concentrated load at the midspan. So first, we will have to convert this inclined concentrated load into horizontal and vertical components. So there are two methods. First is using the ratios based on similar triangles, and second is trigonometry. So in the first, we will apply the concept of right angle triangle and find out the hypotenuse. It is 15. So by applying concept of similar triangle, PV upon P is equal to 12 upon 15. We know P, so we can find out PV as 1000 lb. Similarly, PH upon P is equal to 9 upon 15. Applying this, we will get pH is equal to 750 lb. By using trigonometric principle, we will find out this theta, that is angle with vertical axis. So theta is equal to tan inverse of opposite side of this triangle is 9 and adjacent side is 12. So we get theta is equal to 36.9 degrees. Now one trick. We have assumed this theta with vertical axis. So this vertical will be the cos component of this force. And horizontal component will be sine component of this force. So PV is equal to P cos theta, which will be 1250 lb into cos of 36.9, which we will get as 1000 lb, and pH is equal to P into sine of theta, which we will get 750 lb. Now we have find out these two components pH and PV. From these two components we will find out the support reactions. This is our beam reaction HA, VA and VB, and two reaction components 1000 lb and 750 lb. We will apply equations of equilibrium. Summation of f of x is equal to 0. Considering right hand side force as positive. Always write this sign convention before solving this equation so that you will not make any mistakes in the signs. So it will be HA plus 750 is equal to 0. It will give us HA is equal to minus 750 lb. Now this negative sign indicates that the assumed direction of the force is wrong. So it will be in the opposite direction. Now summation of Fy is equal to 0. We will get V upward is positive. VA plus VB minus 1000 is equal to 0. We have two unknowns. We need to also apply one more equation, that is summation of moment at A is equal to 0. This is the sign convention. Clockwise negative, anti-clockwise positive. So by applying equations we get minus 1000 into this distance is 5 feet, this distance is 5 feet, minus 1000 into 5 feet. Now these two forces and 750 lb passes through the support A or point A. So moment produced will be 0. Now moment produced by VB, it is positive, plus VB into 10 is equal to 0. Therefore we will get VB is equal to 500 lb, and from this VA is equal to also 500 lb. This is how we apply equations of equilibrium for solving support reactions. Thank you so much to you all for being with me throughout this video. I am grateful for your support. Happy learning! For the content in the video, all the credits are given to the AISC committee who prepared the manual detailing for steel construction, and also to the Michelle R. Lindeburg for the FE Civil Review Manual for Reactions Summary Table. If you find this video useful, then please share. It will help others, and subscribe to get notified about the new videos.